Thank you. When I traveled to Austria last fall, I thought I was going there to study cross-laminated timber. And when I got there, I realized what I was actually learning about was the art and the craft of prefabrication. I've been at SRG Partnership, an architect there for about as long as I've been living in Oregon, almost 10 years. I first became interested in cross-laminated timber a few years ago when I was looking for a really simple solution for a small shed roof structure out at the recently completed elephant habitat at the Oregon Zoo. Little did I know what I was getting myself into, and it ended up being the first permitted cross-laminated timber structure in the city of Portland and in Oregon. And since then, I've had the opportunity to dive a lot further into research on the subject. SRG sent 4 architects, including myself, to Europe last fall to study this topic much further. Before I got my architecture degree from Cornell University in 2003, I grew up in Alaska, which, like Oregon, is a timber state, and we have a long history of wood construction as well. This building is about 110 years old. We also have a long history in Alaska of prefabrication. It's a remote location and in an extreme climate, so the fit is right, but it left me perhaps with a preconception of what prefabrication really is. So how does prefabrication really relate to craft? And what I found out in Austria is that really everything. So I asked the internet what the internet's preconception of prefabrication was. I Googled the word prefab. And this is the very top results from the Google image search. So it's really beautiful architecture, high-end custom work. It's also rather small scale. This is all residential, sort of small scale construction. What does prefabrication have to do with sustainability? Actually, quite a lot. So in terms of sustainability of resources, there's an efficiency there, a lot less construction waste, more precise use of materials. If you have enough time in design to think about it, fewer, simpler connection details, and tighter envelope construction. We've seen a lot of talk about this so far. I've been really excited to see in this conference so far. Factory tested systems are more predictable, and if you plan for them, better utility access for upgrades in the future, less demolition in the future. There's also a social and economic sustainability story here. Improved worker safety conditions, more manufacturing jobs, improved worker quality of life with a more predictable commute, more diverse workforce, more women, older workers, better ergonomics for those workers. And in a sector that's seen declining profit margins for decades, better profit margins is a pretty interesting thing to consider. This is a quote that really brings craft and sustainability together. This is a quote from an Austrian architect who heavily influenced Hermann Kaufmann, and we're going to see a couple of his buildings here in a minute. Craftsmen have always used the world's natural resources extremely frugally. They are the ecological models of the future. I love that. So what are we already doing in the region that we know works? We understand the strategy of working with curtain wall. We have a lot of interior systems that are prefabricated components, furniture systems, and so forth. There's a lot of really great research being done in the United States around prefabrication. This photo is from a 2008 exhibit at MoMA about prefabrication. The structure in the back is a Kier and Timberlake project, and that's a firm that does a lot of amazing research on prefabrication and component-based assembly for buildings. This building in the back here went up in about 1 week with all of the systems already installed into the floor cassettes, and so when it went up in that 1 week, it was fully operational. They're doing work at a larger scale as well, a lot of student housing, and working directly with fabricators in programs, BIM programs like Revit, to actually produce the shop drawings themselves so they can actually order and fabricate parts directly from their drawings and eliminate shop drawings and submittals. The structure in the foreground is a cross-laminated timber modular unit created by an architect, Oskar Leo Kaufmann, out of Austria, and this is the precursor for building that we're going to look at in a minute, a hotel. So as we go through the case studies, there's 10 buildings across 3 countries, Austria, Switzerland, and the UK. There's a few things that I really want to emphasize. Collaboration is key. Early collaboration between designers and builders is how prefabrication really works. Clarity and regularity of structure is important. Consolidation and accessibility of utilities. Simple connections for smooth component assembly. And then the craft, the precision and materiality. We're going to start in the Vorarlberg region in Austria. This is an area of the world that has a deep culture of craft, particularly around timber construction, and also a culture of collaboration between designers and builders and of innovation. They've been using cross-laminated timber as long as anyone else in the world. This culture of craft has actually led them to a place where they're finding more and more that they're using prefabrication in their buildings. Up to 80% of the materials in their buildings will come from prefabricated components, some of these architects that we've been talking with. Also, 80% of the materials in the building come from the region, which I think is just really amazing. They have this strong culture of local economy that they keep all of that within the Rhine Valley there. This is a hotel project. This is that box system extrapolated into a much larger structure. It's concrete-based podium and concrete cores with prefabricated hotel rooms, 6-sided boxes all stacked together. There's 96 boxes. They all come with all the systems already installed into each room. And there's a sort of a gasket system between each of the boxes for acoustics. They were fabricated over the course of a month, and this is while the concrete work is being done on site, and assembled in 10 days. And this was really important for this site, which is remote in the Alps, very difficult to get to, lots of windy roads. So having that short duration on this site was a real savings. This is a Herman Kaufmann project. They worked in collaboration with the developer Romberg and their subsidiary Cree on the life cycle tower. This is a little bit different structural strategy. It's a hybrid floor, a timber and concrete floor with a post and beam open plan for the office design. The systems are consolidated in the ceiling. You can kind of see these metal access panels in the ceiling. So all of the systems are consolidated in that floor and in the core as well. One of the innovations in this building that's quite impressive is the simplicity of the connections floor to floor. They're able to assemble this building with 5 people in 8 days. That's a floor a day. And this is, the concept of this building is really a kit. So this is their showroom. You can kind of go in there and pick out finishes, pick out your systems and window types, and then buy basically a kit skyscraper. This is a continued iteration of that same hybrid concrete timber floor system idea with Herman Kaufmann and Cree. This building is 400 feet long. It's about 100,000 square feet, and the goal here was just to get every possible component in prefabricated off-site. And the precision that they were able to achieve in this building is stunning. You can see there's very little trim. All of the tolerances are just so close, practically zero to my American eye. And the collaboration that they were able to achieve with their local craftspeople. This is one of our guides, an architect that works at Herman Kaufmann. His name's Christoph Dunzer. And he's telling us about how he worked directly with the window manufacturer to develop a window latch system that's completely concealed. And he's so excited about telling us about this because this is one of many iterations, and they've been developing this over years. And in the next building, they're going to do something just a little bit different. So it's this deep collaboration on the subtlest of details that really creates these divine spaces in the end. Another architect in the region, Dietrich Unterfaller, did this grade school in Klaus. It's it was completed in the year 2000. It's a timber frame, and it has prefabricated box components inserted into that timber frame. And the structural regularity of the school contributes to the success of that strategy. It also creates these really beautiful open spaces, very gracious corridors. And then about 10 years later, they completed the gym, which has these beautiful box structures that are all kind of rotated to create this variation, and with the natural light coming in, it's just a beautiful long span strategy. Another one of their projects is this celebration really of mass timber and CNC technology coming together into this great creative office space environment. You can actually walk from floor to floor on this really interesting sculptural work. This is the Tamedia office building in Zurich, designed by Japanese architect Shigeru Ban, and it's another interesting use of CNC technology. Very, very small tolerances here. Really a zero tolerance construction strategy. All of the connections are contact connections. There's no metal. It's all wood on wood connections, and the columns are full height, about 75 feet high. And there's 4 millimeter difference between the top and the bottom, so just these very, very small tolerances. And unlike most buildings where we see kind of rising from the ground up, this building actually was constructed frame by frame, so sort of horizontally along the site. So each frame would go up, and then the floor cassettes would go in, all again with the systems consolidated in the floor back to a central core. In the United Kingdom, there's a little bit of a culture shift we found from Austria to the UK. They have really started working with timber a lot, and we've heard a lot of stories about that earlier in the conference. But a lot of that knowledge is actually coming from Austria over, apparently the contractors in the UK have been won over. The learning curve is not so bad, and a lot of them are really only want to work with timber at this point. This is the B-Sky-B campus. It's a big media company in the UK. They're doing tons of construction work on their campus right now, just so many square feet every month. And they've turned to timber construction to create that sort of rapid construction, quiet on-site construction. This is the first multi-story timber office building in the UK. It's CLT floors and cores with timber frame. And you can see that the construction tolerances are a little bit different than they are in Austria, but they're creating these beautiful open spaces just using this timber construction. Again, systems consolidated in the floors. They co-located the design and contractor team for this, and were able to achieve from start to finish, design to the end of construction, all in 1 year, which is really an amazing achievement. And they are estimating that that's about half of what it would have taken with a more traditional contract style. It worked so well that right next door, when they decided to put up their health and fitness center, they used the same structural technology and system and put this building up in 4 weeks. The William Perkin High School is a Fielding Clegg Bradley building, all CLT floors and walls. The structural strategy here was decided after they brought the contractor on board, not too long after they selected an architect. And the contractor looked at that schedule, and they looked at the budget, and they said, we think timber construction is the right choice for this school. They actually opened this school in phases, so it was occupied while they were continuing construction, and they still managed to finish the project 4 months early. And the last building is another building in the UK, the Woodland Trust Building. And to me, this really shows that sort of Austrian sensibility, that exterior wood, really respecting that wood. And they're using CLT for the walls and the floors. It's a little bit of a hybrid structure with steel columns and beams. And the goal here was to actually get that zero tolerance. And so you really feel kind of like you're back in Austria when you're walking through this building. At SRG, we do some healthcare projects, and we're seeing a trend in the industry in some of the more systems-intensive spaces. For example, the ceiling of a surgical room. The advantages of getting that prefabricated ceiling component on site have to do with controlling those systems, the precision that you're able to achieve in a factory setting, and also just eliminating so many of the connections, those field connections. You get a lot more infection control in a room like this. That's so important. So we're really seeing an industry shift there. We're so lucky to be working with the University of Oregon and Oregon State University on modular CLT classroom prototype. We're also working with modern building systems on that. So we're so excited to be able to work directly with the fabricator on this one and start working on sort of that transition from design, bid, build to working on shop drawings and fabrication drawings directly with the manufacturer. And we see this as being more than just classroom potential. There's other sorts of relocated populations like tenants for a construction project or even for disaster relief. And then I hope you all had the chance to listen to Mayor Lundberg and Judith Schein's presentation this morning on the CLT CLT parking garage in Springfield. This is a project that we're just finishing up SD on, and as we've been thinking so much about that structural consistency and regularity as we develop this design. As we move into DD, we're really going to be thinking about those assembly connections and how it goes together. So what are the benefits to designers, owners, and contractors when we look at prefabrication? Well, for designers, it's really about a return to craft. We really want to be able to get back in touch with those materials that we tend to not really know what exactly we're going to get into our building until the bidding process happens. So bringing that back into our design process is a huge benefit to us. Greater quality control, control over utility placement. Right now we just sort of diagram it out and it works itself out in the field. Finer construction tolerances, reducing construction conflicts, and we all want to eliminate punch lists, shop drawings, submittals, and change orders. Benefits to contractors include less schedule risk, being a better neighbor during construction, reducing that noise, traffic blocking, duration overall. It's a great solution for very constrained or remote locations, reducing those trade sequencing conflicts. Site environmental controls improved, worker safety, quality of life, increased productivity, those profit margins, and we all want to see punch lists, shop drawings, submittals, and change orders go away. Benefits to our owners, 50%, up to 50% reduced site disturbance and access time, little or no construction staging area, higher level of quality control. That outcome is just a higher level. System servicing and access in the future, and your as-builts will actually locate those services for future access. The sustainability narrative is always good, and we'd all love to see the punch lists and the change orders go away. So what are some of the barriers to adoption? The traditional contracts that we're using really separate architects and builders. So starting to work with more collaborative contracts is really key. Maybe there's a perception of a low quality outcome or risk, additional cost. Our traditional cost models tend not to know how to quantify the savings and efficiencies that you find in prefabrication. This is an issue that we're seeing when we're trying to price out CLT as well. If I was a contractor, I think I would be thinking about getting a warehouse scale manufacturing facility to start putting together some of these component-based assembly sorts of strategies. And our workforce and our manufacturers are accustomed to more traditional processes, so that's always something to work through. So I really want to impress upon you all that these collaborative contract models are really the way that we need to go. The traditional models really separate the architect and the contractor. A collaborative model like design build or design assist or even better integrated project delivery brings everybody together, so we're all in it together for that outcome. So design is not a linear process. It's a little bit messy. It's not something you really want to do in the field, but right now, the way that we sort of bid our projects after we complete the construction documents to basically tell you how to build it, we then find out what goes in the building, and we kind of have to figure it out all the way through construction. Some of these more collaborative contract models bring that process back into design so we can really know what's coming, start that manufacturing process even during design, and then when you get on site, it is actually a linear process to the completion of the building. Overall, reduces that entire design build construction time. So we're calling that go slow to go fast. Spend a little bit more time in the design phase, spend a little less time in the construction phase. Figure it out before. It's so much cheaper to figure it out in the design phase than it is in the construction phase. It's insisting on those collaborative contract models. I'd love to see more facilities for off-site module assembly and start thinking about sites as assembly zones versus construction zones. And think about craft as happening off-site. And of course, we needed to train workforce in BIM and computer-aided manufacturing processes. But the advent really of all three collaborative project models, BIM modeling and CNC technology all together, I mean, I really think that this is the right time to start thinking about prefabrication as far as we can take it. So yes, prefabrication has everything to do with craft, it has everything to do with sustainability, and collaboration is how we get there.